These two limits look alike. So I put them together for discussion and just for a comparison. Now, first do this one. I multiply by e to the negative x, both top and the bottom. So it becomes x e to the negative x, 1 minus e to the negative x dx. Right? And this is just perfect, the derivative of log of 1 minus e to the negative x. This derivative is this. So that's equal. By doing this way, I can use it by parts. So u dv, u times v minus v du. V is this. U is dx, so it's log of 1 minus e to the negative x dx. Very good. So when x equals 0, this log 1 is 0, is okay. When x equals to infinity, this will be 0. Log 1 is 0. This is infinity. So we have to use something for L'Hopital's rule, right? I leave the job for you, okay? Just use L'Hopital's rule and end up with this 0. For this, I'm using Maclaurin expansion for log function. So this one equal to sigma n equal to 1 from infinity. And it's n minus 1 negative e to the negative x square. Well, simply Maclaurin series, right? Since x is between 0 and infinity, therefore this one is between 0 and 1. So that L'Hopital's Maclaurin expansion is valid. Now, this is equal to let me do slowly here. This some confusing. 1 to infinity. This is n. Now, we have negative here, right? Now, negative 1 to the n times negative 1 to the negative 1, that is this. And don't forget that we have a negative 1 here. If I put a negative 1 there, another negative 1, right? This one is a negative 1 to the n times e to the negative nx. Yeah. So this negative is this. This is this. This is that. This is this. And okay, good. Now, this one, that one is positive 1. This one and that one is a negative 1 to the 2n. 2n is an even number. Therefore, is also positive 1. So everything is positive. So this one is equal to sigma n equal to 1 to this one. 1, right? This is positive 1. And then integral, or e to the negative x dx. Good. So this one equal to sigma This integral is 1 over negative n, right? And e to the negative x 0 to, yeah. So this one is equal to 1 to infinity. This is negative 1 n squared. This is 0, right? This is minus 1. So end up with sigma and positive 1 over x squared. Yeah, that is a famous Basel problem. That is equal to pi square over 6, right? That is our result for this integral. It's amazing, the result. Okay, now, second one, this one. Well, then we do something similar, right? This one is equal to 0 to infinity, x e negative x, 1 plus e to the negative x dx. Yeah. Now this time, I put this out. Okay. The numerator is this. The denominator can be expanded as a power series. This n equal to 0 to infinity, negative 1 to the, it's alternating, and e to the negative x to the n. Right? That's power series for 1 over 1 plus e to the negative x. Since x is between 0 and positive infinity, therefore this is between 0 and 1. So that expansion should be okay. Right? Now then this one is equal to I'll put a sigma notation outside, and 1 over n. Right? Yeah. And then integral, I put an x back. This is 0 to the infinitive, x to the e to the negative. This one combined with that one is n plus 1 x. Yeah. Very good. So this one could be written as negative 1 to the n integral x d e to the negative n plus 1 x multiplied by negative 1 over, right? This one is equal to that. Okay. The reason of doing this, I want to use by parts. So this one is equal to, this is taken out, sigma. Okay. This is negative 1 to the n. I leave the numbers outside. Now by parts. This is x times e to the negative 1 plus x n plus 1 x 0 to this one minus integral this e to the negative n plus 1x dx, right? By parts. And this, I just leave it for you to work out. That is 0. Okay. So the sigma n equal to 0 is negative 1 to the power n. This one cancel out positive, right? Because this, okay, e to the negative 1 and plus 1 x dx. Yeah, this one positive. This one's 0. Then n equal to 0 infinity. This is a negative 1 to the power of n, and this n plus 1. This integral is a negative 1 over n plus 1. Okay, e to the negative n plus 1 x from 0 to infinity. Wow. Okay. This one's sigma notation and equals infinity. And this would be n plus 1 square n, right? Have a negative 1 here. This one is 0. This one is 1. Yeah. So this one is sigma negative positive. This one is negative 1 to the power of n plus 1 to the square. Yeah. Okay, what is this? Interesting. What is this? This is alternating series. So this one is equal to 1 minus 2 square, right? Plus 3 square minus 4 square plus 5 square minus 6 square, and so on. Now, how do we calculate this? I'm using this way, okay? This is equal to 1 plus minus those evens, minus this one minus this one, but it's not equal to that. This minus this one becomes this. So if you want to keep the negative, you have minus another one, so the minus twice. Then they are equal. Okay. This one, yes. Okay, then this is this, right? n equal to 1 to infinity. Yeah, that is this one. This one is this. Minus twice. That one is sigma n from 1 to infinity, even numbers square. Okay. This one is this. This one is that. Okay. Yeah. The other one is pi square over 6 minus, this is a 2, right? This is a 4. Out becomes n squared. Yeah. Okay. This one is a pi square over 6 minus 1/2. This is also pi square over 6. So therefore, this is equal to pi square over 12. That is what, what we want. So this one is equal to pi square over 12. That is for this integral. Okay, I hope you follow it. And these two integrals are very interesting. Yeah, this one is this. That one is equal to this. Thank you for your watching.